Pro online with the giant Hostinger sale. VPS hosting now starts at just $5.99.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve n queen. So this is a pretty famous backtracking problem, and we're finally going to be solving it today. And this is marked as a hard problem, but I don't think it's super hard to come up with what the solution would be, at least to come up with how to solve the problem. I think the hard part about this is actually implementing the code of this problem. We have a column set, we have a positive diagonal set, and remember the positive diagonal is determined, let's just place a comment, is determined by r plus c, and the negative diagonal is determined by r minus c, so let's just make sure we remember that when we're actually writing our code, r minus c for the negative diagonal. And we're going to have a result, which is basically going to tell us all possible n queen solutions. And we're also going to maintain a board. So initially, I'm just going to make the board a array of, let's say, and by the way, I didn't mention this, but a dot is basically indicating an empty location. So this multiplied by n is going to determine a row. How many rows are we going to have? Well, for I in range n, right? It's an n by n board. So I'm just initialing a board with periods or dots in every single position. So then we can define our backtracking recursive function. And remember, we're going to be doing it row by row. So initially we're going to start at row 0, then we're going to go to row 1, row 2, all the way until we get to row n. Row n is our base case. That means we're out of bounds. That means we already completed every single row. So if we ever reach this position where row is equal to n, that means we were able to find a valid n queen solution. So what can we do? Well, of course, we're going to return, but before we return, we're going to add whatever the current board is, and we're going to add it to the result. But we are going to make a copy of this board because we're still going to use it in subsequent function calls for this recursive function. So we're going to make a copy of this board, and we're also going to change the formatting the way they want it. Each row is not going to be an array. Each row is going to be a string. So we're basically, for each row here, we're just going to join each substring together. So let's make a copy of this board, which we can do by taking for, let's say, row in the board. Each row, we're going to take each row and then join it together. So we can do that in Python like this. Empty string dot join this entire row together, and then doing this, we'll have a copy of the board where each row is basically joined together, right? And then we're going to take that copy and append it to the result. So result.append copy. I mean, I'm sure there's different ways you can do this if you're using Java or C++. This is just an easy way to do it in Python. So if we did not reach the base case, that's when we're going to continue. So we're going to go through every single I in range of n, right? We're going to try every single position in the current row that we're at, and we're going to see which positions are we allowed to place a queen inside. And this I actually refers to the column, so I'm going to change it to for C in range n. So basically, if C is in column, meaning it's already been used in this column, or r plus c is already in the positive diagonal, which means the positive diagonal has already been used, or if the negative diagonal, r minus c, has already been used, that's how we know we have to skip this position. So what I'm going to say is continue if that's the case. That means we're not allowed to use this column row position. But if we are allowed to use this position, let's do exactly that. Then we can do a backtracking call, do the same thing, backtracking call. Let's go to the next row. But before we do that, we know we have to actually update all of our sets, right? Because we weren't using this combination, but now we are using it. So we have to say column.add this column, and we have to say positive diagonal.add row plus column, and we have to say negative diagonal add row minus column. So that's just kind of some of the pre-work that we have to do. And we also have to update the board itself, right? We have to say, okay, at this position in the board, row, column, let's set it equal to a queen, not a dot anymore. So that's what we're going to do before we start our recursive backtracking solution. And after we're done, we have to do the cleanup that is required in most backtracking solutions, right? So we have to basically do what we just did here and undo all of it for the next iteration of the loop. So I'm just going to copy and paste this because we're literally just going to be having to rewrite every line. So instead of adding all of these to the set, I'm going to be removing all of these to the set, right? That's kind of what backtracking means. We're backtracking from what we just did, seeing if maybe multiple solutions exist, right? That's the brute force element of this. So we initially set this equal to a queen. Let's set it back equal to an empty space or a dot in this case. And that's really it. We have no return condition in this backtracking. So once this loop is done executing, then we're done with the entire function. So now outside of here, all we have to do is call our backtracking function, passing in row 0, and then once that is done, we will have updated our result. So our result should contain everything we need. So then we can just be able to go ahead and say, okay, return the result. So you can see that this Hey everyone, was a single position. So then we can define our backtracking, and we're going to add it to the result. But we are going to make a copy of this board because we're still going to use it in a subsequent function called calls for this recursive function. So we're going to make a copy of this board, and we're also going to change the formatting the way they want it. Each row is not going to be an array. Each row is going to be a string. So we're basically, for each row. So we're going to go through everything in this column or to use this column